That we call it as exploratory analysis. Okay. The fourth step, is once we perform your exploratory analysis, then in your analysis, you also need to build up the story. You also need to define what are the improvement factors, or what are the um, let's say different uh, means improvement factor is there, or what are the different measures that the business stakeholder will take. Okay. um, while do this exploratory means after with this particular problem state. So what are the actionable insights that stakeholders will take? Okay, with the problem statement. So you can say that actionable insights derivation. Derive actionable insights. Means
Sir, can
your
you please
analysis,
repeat?
yeah, your analysis should be in a way so that you can derive some actionable items. What do you mean by actionable item or actionable insights? So basically, let's say uh, a particular patient is suffering from cancer. Now you are saying what are the top three reasons for that patient of suffering from cancer. Now in that top three reason, okay, for the first reason, what should be the actionable item for a patient so that he can avoid of getting affected with cancer, as per the first reason. Okay, so the first reason is something XYZ. What actionable insights that we can take it on, okay, for that particular patient, so that he or she may not affect with cancer. This is one type, one example. The other one is like, if a patient is going to suffering from cancer, what are the reasons, causal factors of patients suffering from cancer, and how much contribution of those causal factors are there across all the patients. So one causal factor you will get it at a patient level, means every patient have a different cause, right? Every patient has a different causal factors. And another analysis that you can do is at the population level, where there could be 10,000 population, 1 lakh population, right? And even more than that. At that point in place, uh, you just need to understand what are the key factors of the cancer population, what are the key factors that is driving the cancer population, what are the key factors responsible for getting cancer. So these are your uh, actionable insights, and in using that you can understand if you can rectify the top three feature or top three factors, definitely you can. And this problem statement is not only specific to sorry, not problem statement, we haven't gone into problem statement. We are still doing into an exploratory analysis. It's a static mechanism, can be fitted in any given problem statement, not only with the example which I gave. The other example is like, let's say a patient, sorry, a customer. Let's take a customer in a retail business. We basically try to understand whether the customer will churn or not churn. So we say churn if the patient, if the customer doesn't buy anything in the current year and has already bought something in the previous year, and that we call it as churn. So the logic that I said, that the patient not buying anything in this year but actually bought something in the year first year, this logic itself we sometimes need to derive as a part of your problem statement or problem definition design. Sometimes it won't be very clear. The business stakeholder will say that we want to predict churn rate, okay, and we can take this use case, uh, and everybody can give some low lights. We want to predict churn rate, let's say, or we want to understand. Let's forget about prediction. We want to understand that uh, how to identify the customers who has already churned versus the customer who has not churned. And the assumption on the data side is you have 3 years of data. Year 2020, and year 2023 is still running, so complete data is not available, but these 3 years you have complete data. 2023 is still running, you may not have a complete data and maybe other challenges. Now, can you guys brainstorm a bit, okay? And this, we can do it live, like everybody can give their own thoughts. How can we say a customer, okay, is churned or a customer is not churned? Meaning of churn is whether the customer left. So let's say you are, let's say we are, let's take the example of Walmart. So customer used to buy everything from Walmart. Suddenly customer stopped buying everything from Walmart. And maybe there could be many other reason. We don't know the reason because customer is not visiting the store. So we don't know the reason. Maybe he has shifted from that particular location or that particular city to another city. Or maybe the services of Walmart is not good. Because of that, the customer might have turned into a different, uh, we can say, stakeholders or the different store and left Walmart. So there could be many reasons, okay, but we don't know the exact reason because we are not having that information of from customer. That why you left, because customer, we don't know whether that customer is a churned customer or not. So our problem statement is determine the churn rate and tell us what are the causal factors of churn rate. Okay, guys. So this is your problems definition. Now, the challenge that we will face is how to identify which customers are going to churn and which customers are not going to churn. Okay, and let's brainstorm this. And this is how we actually develop problem definition. How to solve, how to think on this particular approach. Okay, so let's brainstorm together. Anybody can just take some time, 1 or 2 minutes. Think on this problem statement. How will you define? You have the information of year 2020, 2021, 2022. How will you define whether the customer will be getting churned or not churned?
Rishabh, we will consider the buying pattern of the customer. So if let's say if you talked about the Walmart, so we will study whether the customer in the what how much he bought goods from the Walmart in the year 2020, then 2021, then 2022. So if it is decreasing trend, then we can consider that customer might have churned.
If
Or
it is a decreasing trend, okay.
yes, yes, yes. And other factor that came into my mind is uh, whether there are any
But how will you
issues.
define? How will you define that threshold that this is a decreasing trend, this is an increasing trend? Okay. How
So
will you
we
define that threshold?
we will take a average of the buying pattern uh, of
Mhm.
of the customer's age bracket. So let's say if he is a household customer and we find it that
Mhm.
his buying goods are decreasing then on a certain age range, then we can think of that customer might churn.
Okay, so in that case, there will be a lot of biasness getting introduced. Okay, so
Yes.
for an example, it means you are purposely trying to tell that there could be customer. Let's take a hypothesis. There is customer X. Okay, the idea is good, but you need to also keep these things in mind. So customer X is there and customer Y is there, right? Now customer X says that uh, I need uh, 10 biscuits. Customer Y says that I need only 5 biscuits because I have only 3 members and here I have basically 5 members. So the demand that everybody will have based upon um, their own family, their own circumstances, their own needs, right? So eventually, if you try to do average out, things may not work, specifically in the retail sector. This is one cause. The other cause is customer X is of a high category of the same age group. Let's say the age group is between 30 to 45. Okay. Customer X is of a very high category customer who doesn't take normal biscuit but mostly go for some branded, some you can say prefers some top-notch brands biscuit. While customer Y is a it's a it's a normal customer like mediocre products is fine with the normal biscuit that the store has. Okay, but while customer X will only purchase multigrain biscuits, customer Y can purchase anything, whatever best fits him. So that's the idea. Like if you go by average uh, spent or average orders, okay, that eventually will vary. Okay, from customer to customer based upon multiple factors will be there. Age is factor. Okay, what uh, income group these customers are in, because you don't know that group, so you need to explicitly figure out, and nobody will tell your income, their income for the purpose of store. So you need to do a lot of analysis to segment out those set of customers which are a high budget customer, those set of customers which are medium budget and low budget customers. Okay. but still the idea is good. What else can be done? Like we have a lot of disadvantage. If you have any idea uh, where you can bypass this disadvantage, then you are welcome to define.
Rishabh, we can pick up the trends since we have 3 years database. Or we
Mhm.
can pick up the trend of previous 2 years and look at what is the average spend of the customer. What is
Again,
the
the problem
average?
statement remains same. If I take the average spend, okay, for some
Mhm.
customers, the quantity is less. The average spend will be
Have
also
to,
less.
by
So
customer wise, we'll have to bucket this data into what is their specific buckets in which they fall. What is their average spend in the last 2 years and compare third years. So what you're saying is problem statement is to predict churn in third year, right? Whether these customers are
yes,
going.
yes, yes.
So basically pick up the trend from the first 2 years, customer
Mhm.
wise, and bucket those databases. And then in third year, compare what is the percentage of drop in average number of visits or average spends. And if it, if it has dropped by a certain percentage, maybe that, I think that threshold will have to work upon. If they have dropped by 50%, 60%, 70%, or something like that, then we can predict that this customer is on his way out. Or if he has completely stopped
Mhm.
buying from that particular store.
Okay. I'm still bit not convinced with the thresholding piece,
Okay.
because
Okay.
threshold is very ambiguous in nature. Means we as per my strategy, I try to avoid threshold. What else can be done with in order to identify whether the customer has churned or not churned? And there are a lot of disadvantage with threshold. So the customer may spend a lot in past 2 years and may spend $0 in over here. So that also you don't know, right? Your average spend will be very high. The customer has spent, let's say, $20,000 here, or 20,000 rupees, whatever you want to define. 500 rupees here. Spent is 0 rupees here. Overall spent is 20,500 divided by 2. That's 10,250. This is the average spend for customer X. But in current year, customer has not bought anything. So you cannot go with the average, first of all. I agree with the trend that if the trend coming down, then definitely you can capture that trend of spend coming down. But how much down? What percentage of down? Down has some definition, some threshold, that it is 10% down, 20% down, as you rightly mentioned, 30%, 60% down. What threshold we should capture? 10% down, that 20% down, that threshold. What threshold we should capture? Because we don't know the threshold. Okay, the one approach can be, I can take an average threshold, but again in that case it still works. It is still a better idea taking an average threshold of trend, of trend, where your trend is basically saying that, okay, 20,500 0, percentage is very fluctuating in over here itself, right? First of all, it is spending 20,000, and the next year it is 500. So it's almost not even 1% spending in next year. Right? And again, this is a good approach to go with trend, but again there could be a disadvantage. Okay, but that disadvantage is very rare. So I'm assuming it's you need to think on all the aspects. Okay, before you define your problem state. So the disadvantage could be, let's say in that particular year you are settling up somewhere. For that reason, you have spent a lot. Doesn't mean that every year you will spend a lot of amount. Let's say you purchase the TV from Amazon. So you will purchase TV once in a year. You will not purchase every year, right? So for that year, your spent will be very high, but for next year the spent will not be very high, right? So that's a disadvantage in trend analysis.
So in that case, Rishabh, we can consider the number of visits that are being done to a store. So if visits are decreasing, then we can probably have a trend of
Yes,
decreasing.
that's a very good point. Visit. Okay. Visit is a very good point, and let me erase all of this. So it comes. Visit is a very good point. Okay.
I think instead of looking at only the total spends, we must look
Hmm.
at other parameters also. Uh,
Okay. What are those?
like, visits is one, number of
Ah.
products purchased, average
Hmm.
spend. So, like you said in 2020, if his spend was 20,000, was this 20,000 spread across number of products, or was there a single product that he had purchased, which was a high value item purchase, right?
Correct.
And so, what are the number of products, average number of products purchased in 2020 and average number of products purchased in 21? Is there a decline there also? Is there a decline? So
Correct.
basically, multiple features. We have to now, instead of picking up one single feature, we'll have to select multiple features and then see what is the trend over there instead of relying only on one spend amount to go with.
Okay. So let's say you are taking number of visits, you are taking number of products, you are taking okay, number of visits, number of product, and what else?
Average
Average spend on
spend,
each of
average
uh,
spend on each visit.
each visit. Okay. Uh-huh. Average spend on each visit. So let's say combining these three, okay, and there could be many more such features, right?
Right, right, right.
Let's say combining these three, how will you determine what exact mechanism you will apply to define churn rate? Okay, let's dig more detail. Let's say we take these three: number of visits, and then number of product purchased, and average amount spent in each and every visit. Using these three variables, three features, how will you determine the churn rate for customer X and churn rate for customer Y? What exact logic you will apply? Let's brainstorm on this.
So first of all, we'll see what is the most important feature here. I mean, if customer
You
is
cannot define that. What is the most important feature? Because you don't know what is the most important feature out here.
So my point of
Means
view was that if the customer number, or suppose if I say that number of visits is an important criteria from where I can measure customer is not, it has not
means
checked
you have
out.
the choice. So you can go with any of these three. You can go with any one. So choice is yours. Means as per the problem definition, the stakeholder only want that what is the churn rate. Stakeholder uh, doesn't know the methodology of what you are going to apply. It's completely on you. Yeah. So that's the assumption. Okay. So
Mhm.
let's let's brainstorm on this.
If the number of visits to store of a customer has not declined, and his maybe his average spend is going down, that could mean that customers, maybe he's in a certain phase wherein he basically his spends have gone down for some reason, but he's still actively engaged with the store. Or maybe one high value item he had purchased initially, and now basically certain values which are of a very high amount, if we take that out, suppose if he has taken a TV, right, which is a very high value item, in
Correct.
comparison to his average spend, which could be on biscuits and chocolates and whatever, which are very
Mhm.
in comparison to TV, which are low spend items. If we take out that value of TV out of this database, how does the trend again look? So is it that
Okay,
20,000,
so
19,000 was TV, and 19,500 was TV, and then another 500 rupees was biscuit chocolate? If that was the trend, then customer till 2020 and till 2021 was on an average spending 500 rupees only on these, on these chocolate biscuits or whatever low value item. So there is this one value is showing you a data in a different light. But if you take out that bigger value, then the average
Mhm.
spend of the customer in the 2 years have remained the same. And third year
Okay,
could be,
so
yeah.
the one way that you are saying is basically a kind of a time series analysis. So what we do over there is we take us we might have a lot of different ups and downs, whatever it is. We remove all the trend. Ups and downs defines trend, right? So you have spent 20,000. Again, you came down to 500 because that is your average spend. It's 500 rupees you are spending. That is normal average spend that uh, the patient makes. Sorry, the customer makes. So you are saying that remove all these trend and put the data in a stationary data. Okay, put the data in a stationary form. Once you put the data in a stationary form, so you're excluding all those trend. It can be any given high trend. Stationary form means data which is stagnant across all the month, all the year. Okay, for 2020, 2021, and 2020. So whenever you are removing those elements of those trend elements, your value will be very static in nature. So you will not get the trend component over there. Trend component is removed because you cannot go with particular items like those which are high valued items. I will remove that. No, because I will give you a supporting statement over there. So the statement is, let's say customer Y is a fan of branded product. So customer Y is always in love of buying branded product. So even he buys a smartwatch of Apple, which is 80,000 bucks, while customer X is also buying a smartwatch, but he is buying a smartwatch of Fast Track, which is 6,000 bucks. So not even 1%, 10% of it, right? So you cannot go by categorizing the item, nor you can say that spending above 5,000 on an individual item is marked as um, let's say a high budget product. You cannot even conclude in that threshold that spending greater than 5,000 or spending greater than 10,000, because you don't know. If you introduce that threshold, then it is a biasness for our data set, biasness for our decision. Then you have to say that assuming that all the spend which are greater than 5,000 are treated as an high budget uh, product. And again, this problem statement may not fit with some of the industry use cases, because let's say you are doing this churn rate analysis for some high valued brand, so their valuation will be always higher, and they have a niche customer segment. Let's say Apple has a niche customer segment. The valuation is always, and you have a static. So the example that we are taking for Walmart comparatively is easier than the example of Apple, because in Apple they have a their spend is almost equivalent, right? The amount you buy, the amount you spend in buying the phone, the same amount I spent in buying them, right? So if you for this use case of Walmart, you can do this. You can remove the trend component and you can keep the stationary data. But as I said, that even this stationary data, once you keep that, so for customer X, this stationary data might be on an average in a range from 500 to 1000. For customer Y, the same stationary data may not be in this range, maybe in a range from 2500 to 2700. This is the range of stationary data. So every customer will have a different range because of their own spending habits. Now when you go and try to compare the threshold between customer X and Y, you will see that customer X is spending very less, but it is its habit, it's his need. Okay, whatever his need is, he's doing the purchase. He's actually spending that for his own need. So you cannot say that customer X is spending less, the trend it is below average, so he's likely to churn, because his demand, because you don't know the demand of every customer. His demand may be contradictory with the demand of customer Y, right? So what else can be done, or how can we address this particular issue? And similarly with the number of products as well. Okay, because you want 5 biscuit, as I gave an example, I need 10 biscuits because I have 5 members family to feed. You have only 3 members family to feed. So demand is such a thing, um, it's very contradictory until you know that population. Okay, and you cannot estimate every time. So you can only estimate demand at a population level, not at a individual or a member level. At a customer level, you cannot determine the demand at this stage. Okay, if we are in a data science, we can do that, but in data analytics, we cannot estimate the demand at this point only. We need to do a lot of things. We need to run a separate project to identify the demand. That itself is a separate project. Okay? So what else can be done? What else? Just give a thought. The ideas are very good, and really it is very good, but let's brainstorm more. It's a brainstorming session. So what else can be done to address these problems? Yeah, anybody, just give a random thoughts. It's fine. Like if it is correct, wrong, right. Just this session is just to develop that analytical thoughts. Okay, the session is just to develop these analytical thoughts, so that when you take a problem statement, you can think in the similar way, and you can finally address your problem definition. Okay. What else can be done in order to determine the churn rate? And even if you are using those three parameter, number of visits, number of product, and average spend, how are you going to determine the churn rate using those three parameters? And if you are not using those three parameters, then what other mechanism that you want to apply? What else, guys? Please participate. Then only we'll learn. So, as I said, it's a brainstorming session. Nothing wrong over here.
So, Rishabh, another way is to look at the from the customer service level. We can check if any complaints are raised by the customer in the last year or in the recent time. So, if there are complaints being raised and they are not resolved, then we can think of that customer might churn.
Okay, yeah, that's a good part. Okay, so one way of doing is a very simple. One way of doing is, if a customer complains in any of these years, and the survey rating is very poor, so he or she is more likely to churn.
Sure, correct.
Correct. But here is one disadvantage. You can say that only 30% of people fills survey, and while filling the survey, most of the people do have a lot of biasness in it. Means that if you are happy, you will not write it that I am happy. You are happy, you will just ignore, yes, it's fine. But when you get pissed off with something, when you are not happy with the service, then you come and fill it out the form, so that that information is passed to the respective business stakeholder. So this is again a, you will get to see, means the idea is good, but fill rate of the data will be very less, because very less people will come and uh, will say that I will fill the survey irrespective of whatever service we got. Very less customers will basically put a survey. So you will not able to capture the entire population.
So, Rishabh, that's the idea. If people fill up the survey that they are not happy with the services, then those customers have the high probability of being churned.
Yes. So let's say my point is only this. Let's say you have 100 customers. 30% is filling survey, right? So
Correct.
out of 100, you came down to 30 customers. And out of 30, let's say, out of this 30%, 60% of them are unhappy. Means 60% of 30%, which is I think
18.
80, is basically unhappy customers. But now, now the challenge is your actual churn rate is 60%, but when you try to map this 18 with this 100, then it becomes 18%, which is incorrect, because 70% of the customer, they didn't fill the survey, right?
Okay.
And when you say that 60% of them is unhappy, is likely to churn, then it is a very, you can say, risky statement for a business. 60% customers are going off, likely to go off. It's very risky. So these are the like real time scenarios I'm talking about. In real time, this is what happens. 30% is the fill rate of survey. In that 30%, 60% and people those who fill survey are extremely dissatisfied or unsatisfied, suffering from some sort of anger or some sort of challenges, and because of that they're feeling negative service more. Very less often you will get to hear a positive survey, means in a real time situation. The idea is good, but the challenge is with the data. Okay? So how can we proceed? What else can be done?
So, Rishabh, can't we have a company specific strategy wherein we take a survey from all 100 customers and then decide who, who all customers
Then
can be
you
churned?
can. Okay, this is a good point. That why don't we leverage all? But at this moment, you have this information, right? If you want to put this as a practice, you need some time. So you have to wait for, let's say, another 6 months to start this project, because so far it was not in practice of taking survey. But as in order, as in case that you want to measure the churn rate, so you want is to perform a survey. So it will be a 6 month of delay in the entire project. And again, there is a lot of manual tasks that we need to uh, go through. But the challenge only is I want to tell the churn rate now. The project is now. You cannot tell customer that, oh, go and get this 100 survey first and then come to me. I will tell you whether the how many of them are likely to get churn. Customer will say that I don't need to come to you. I can eventually read those comments and I can put let's say 1 to 5 star, and I can say that those who are giving less than 3 star are likely to churn more. I don't need to come to you to do this analysis. I can easily do that just by saying that how many how many customers are rating less than 2 star.
Rishabh, we can first find out what is the actual. So now this is a trend of database, right? Some customers are showing a declining trend on whatever features that we may say, but there could be an actual database of customers who have churned out. We need to study that, and in
Who has
comparison,
turned out that information is not there with you. Then this entire purpose of this project will means the entire purpose of this project is to identify who is likely to churn. It's so you don't know who has churned out. As a customer, Walmart doesn't know how many customers have churned out. That's why they came to you to understand. Please tell me how many of them will churn out, or what strategy you will put to identify that these are the 10 customers who is likely to churn in next year.
see, my point was if we actually know the definition of customers or the features of customers who've churned out completely, then we can compare with the database with the customers who are still in the process of either churning out or regular, and then predict
What strategy?
that
This is just what would be the strategy? This is just English. I need
Hmm.
strategy. What would be the strategy to identify that? I know we can compare between years and all, but what is that exact formula? Compare. And I think rest of the folks, please try to add some points. Um, the rest of the people try to brainstorm. I see only activity from 2, 3 folks. Please try to contribute your thoughts as well.
So, Rishabh, churn rate we can understand as a attrition rate as well,
Yes,
uh,
yes,
like in
but
resource management we do, or in
yes, you can compare both these together. But in resource management, your resource come and say that I'm dropping my paper. But here the customer doesn't come and say that I'm no longer going to use Walmart. That's the difference. You
so
know
there
how many
we can
resources
get a data,
are
but
designed.
here, here the problem is we didn't get the proper data.
Correct. we don't we don't get that information that who is going to leave and who not. In attrition, we come to know that 10 people resigned. In attrition, the major problem statement is why they resigned. But here, the first problem statement is who will resign. Who will churn out from Walmart? And then the next question comes, why they have churned out. Here the why comes later.
Hmm.
But first question is who.
So here, I think we in this scenario we work on assumption only.
Okay. So what would be our assumption? What would be our methodology to assume?
So can we do as like lost customer up till now, and initially the total number of customers with whom we just started?
Okay, that's a good point. So how will you define that lost customer with the total number of customers?
From the database only, whatever we have, like initially, uh,
Okay, so
like,
we have 3 years of data. So you are
mhm.
saying that in all 3 years, so that is not at a customer level, that is at a business level. That okay, we started with 2000 customers. Um, let me erase all of this, and we lost uh, 200 customers, left out with 1800 customers, right? This is what you are saying, right?
No, 2000 only.
2000 is the starting number of customers that is present in the year 2020. In
E-
2022, we have lost 200 customers. Means in all these 3 years, total number of customer we lost is 200, and we are left out with 1800 customers. This is what is the lost customer, right? This 200 is combining all these 3 years. But the challenge is um, this is good, but we need to reframe this in a proper manner.
Okay.
Means the idea is good. Even I am thinking in that way. Okay. but we just need to put it in a more constructive manner. Okay, so let me tell the methodology.
How do
And
we
if you guys want to
how
try,
do we
if you want to try, I can give some more time. Uh, yeah, sorry, somebody was saying.
I'm saying, how do we arrive upon which are the lost customers?
So, how do we arrive is, so the customers who are visiting in 2020, not visiting in 2022,
So customers who have
or
not
visiting in
visited the
2021, not visiting in 2022.
Okay.
Okay, so let me tell you the answer. Okay. Basically, my approach would be a bit different. I'm not going to go into the amount. I'm not going to go into the number of product. Those are my features, which I'm not going to immediately use it, but I will use it in my modeling purpose. Okay, but how will I define a churn rate is something that I want to specify as a visit pattern. Now, visit pattern doesn't mean how many times I'm visiting. A person might visit very frequently, purchasing less number of product. Person might visit once a week and can purchase entire 1 week of product. So there are few customers who will go every alternative days, 4 days a week. There are few customers who goes only 1 day a week. That is their behavior of buying. I don't want to interfere there. I cannot say that visiting once means more likely to churn. Visiting 4 times means less likely to churn. Both can churn. It is just their buying behavior, right? What I'm going to say is at least the customer should visit once in a year. Once, one, and let's take 2022. I'm excluding 2023 because I don't have a sufficient amount of data. So I'm excluding 2023 and I'm going to predict for 2020. So 2020 and 2021, a customer has visited at least in 2020, at least in 2021. Okay, more likely to visit. I will mark it as a active and dormant. Okay, I will mark with blue color. Is an active customer. Now come over here. The next pattern can be 1101. Now in this case, 2020 customer has never visited. In 2021, customer has visited, and it is difficult to explain in 2022 because this customer is a new customer. It can be a one-time visit as well. So it has a probability of 50% getting churned and 50% getting retained because he is a new customer. So I'm going to exclude this particular pattern from the data. Now 10, 1101, 10, and 00. 00 will be not there in your database, right? Because neither visited in 2020 nor visited in 2021. So this particular pattern will not be there in your database because nobody visited. 10 means in 2020 the customer visited, but in 2021 customer has not visited at least once. More likely that in 2022 he will not visit. So it's a doormat. 01 again is a new patient, new customers. This is a new set of customers. So it's more likely, uh, it's difficult to identify whether the customer will be active or a dormant. Any questions or doubts? And you can also define if something I'm missing out of determining the rules for identifying who is going to churn, who is not going to churn. 1 1 active, 1 0 dormant, 0 1 new customer. Exclude as of now those customers from your sample because we never know. And 0 0 will not be there in your data itself because not visited any of these years. So it means that data will not be there with you.
So Rishabh, I think that to give to make a customer as a new customer or a dormant customer, this data is very limited. Maybe probably in 2020 customer has visited for as a one-time customer and then he has not visited and we are considering it as a dormant, or maybe in 2021 the customer who have visited is a one-time customer. I think data is too limited to tag them as a new customer or a dormant customer.
A new customer I'm not including in my analysis, right? That's what I said. I'm excluding.
Okay.
I'm excluding new customer. I'm only taking 1 1 and 1 0.
1 1 and
Either you visited in both the years or you have visited only in 1 year. If you are visited in both the years, you are an active. See, in retail industry, you need everyday biscuit, you need everyday tea, you need everyday milk, you need vegetables every week.
correct.
So the you should actually purchase everything from Walmart. That's the assumption of Walmart. You cannot purchase. It's if you are not purchasing biscuit, let's say every month you need biscuit. Every month you need uh, some spices, right? If you are not purchasing it, then you are actually purchasing it from a different place. You're not purchasing from Walmart. Doesn't mean that uh, you don't need it. At least in a year, and I'm not saying every month come and visit. At least in a year, you should visit at least once. That's the very minimum criteria. If you are not visiting in the entire year, means you are not contributing anything in the revenue. And if you are not contributing in the revenue, then I am assuming to make you put that particular customer as a churn. in 2020. Now the question is, if I get a new year, let's say now we have the data of 2023 full, then again the same algorithm will work, but more number of combinations will come. So let me write down these combinations. So 111, first we'll start with 0. So 0 0 0 0 0 1 0 1 0 0 1 1 1 0 0 1 0 1 1 1 0 1 1. This is excluded because this data will not be there in your database, not visited in all the 3 years. The entire data will not be there in the database. 0 0 1, this means it's the customer is first time visiting in 2022, so it is very hard from his visit pattern in the previous 3 years to define whether this customer will be churned or not churned, because in previous years the customer never is visiting for the first time. So this is a new customer, so I'm excluding it from my analysis. Now I'm left out with these patterns, 1 2 3 4 5 6 patterns. I'm left out with these 6 patterns. Out of these 6 patterns, we need to determine who is active and who is dormant. So this clearly says that it's an active. All the 3 years is visiting. 10101, this is also an active. 011, this is also active. First determine all the actives. 010, this is dormant. This is also dormant. This is bit contradicting. 110 means previous 2 year visited in 2022, he didn't visit. If I put it as an active, I have a justification that in 2020 and 22 years he has visited out of 3. If I take it as a dormant, I still have a justification because in last year he didn't visit it. Okay, so I can put it as a dormant as of now, though I am introducing a biasness, but it helps me to early identify, maybe they are going to visit, but it helps me to early identify those customers who are more likely to churn. So it is going to give me an early identification if I put it as a dormant. Maybe they are likely to visit, that is good, but my assumption is to early identify. My objective is to early identify. That's it. So like this, you can automatically you will have to write down your logic in a way. So all these patterns are captured, and finally you get dormant, active, flag. So this is one approach. There is another approach. This is a rudimentary approach. approach, okay, where you are defining which is active, which is dormant. The other approach can be, now that's a data science approach, typically not a part of data analytics, but this is a data, for data analytics your viewpoint is different. For data science your viewpoint is different. For data science you go for a prediction point of view, right? So when you go for a prediction point of view, just simply take within that period, if the customer is visiting, mark it as 1. If the customer is not visiting, mark it as 0. That's a data science approach, and it can be any given period.
Rishabh, how do you differentiate between data science and data analytics?
In analytics we don't land into predictions.
Okay. So
We basically do the analysis based upon the problem statement, like we are doing the analysis based upon the patterns, right? That
okay.
taking a customer, which category we are falling. 001 category, if the customer is falling, we are saying it's a new customer. 010, we are saying it's a dormant customer. 011, we are saying it's an active customer. Okay, so we are defining the different patterns of visit. We are getting into too much of detailing of how the visit pattern is, at least once in a year. Okay, not into how many times it is visiting, but at least once in a year. And there where the difference comes in. If it is a data science project, we would not get into these details. These details we would get in if it is we would do it as an EDA process, exploratory analysis. But for predicting, we would just need a period, and within that period, out of 100 customers, how many customers are visiting my store? That's it. That is my active customers. The number of customers not visiting my store. At least once you can apply this logic. At least once visiting the store in a year, 2022. And the customers not visiting the store in 2022. Mark them as 0. Not visiting at least once. Okay. And here visiting at least once.
So in this course, our focus will be more on analytics or data science?
It depends. Like the problem statement, if the customer says, if your customer, if Walmart comes and says that, please tell me which set of customers are going to, please predict the churn rate at a customer level, then you will more focus into the data science piece. If the Walmart comes and says that please do a case study on why my customers are leaving, or why my customers are getting churned, or what are the main causal factors, what are the visit patterns. If they want to know, the explore, if they want to explore the problem statement, that's a data analytics. If they want some outcome at any given levels, maybe at a business level, maybe at a customer level, maybe at any given level, then it can land up into, whenever the prediction part comes, you land up in data science. Whenever the analytics part comes, where you just do the analysis, that's it, you land in data analytics. There will be definitely an overlap. There are a lot of overlaps between data analytics and data science. Data science piece will be more concentrated in developing mathematical function, okay, getting into too much of technical detail of how we are going to address the problem. Data analytics is a bit different. We don't get too much into the algorithm structure because here we are just exploring the stuffs. Our objective is not for prediction. So whichever project where we don't do any prediction, just simple exploration, we put it as a part of data analytics. Wherever prediction comes, developing mathematical models, putting your data sets into a predictive algorithm, there where you basically land into data science. There are many things more added in data science, but you can still use, means in industry data analyst still use few basic predictive algorithms. Those are basics, not very you can say not very uh, heavily loaded algorithms, but some basic algorithms can be utilized for initial level analysis. It's not completely out of the box of predictive analytics, but the ratio is bit lesser. That's it.
Okay. Okay. So analytics would primarily be EDA part of it, and few basic prediction
Yes,
techniques. Yeah.
that's the major objective of analytics, and the major part is collating all this data. That's the, like, if you take 100 days of what data analytics analysts to do, 0 to 100 days, 70 days he will spend time in collating all the data set. 30 days he will spend time in doing the analysis.
Right. I believe data cleaning is the most important and most tedious
Yes,
task. Yeah.
yes, correct. And cleaning does not mean only from using Python, but at an SQL level and
Mhm.
all those levels, cleaning is required.
Okay. So now, how do we predict? Are we going to do any prediction? What technique are we going to use to predict the churn here? So
Yeah,
what we
at a
already
at
have,
a
yeah.
at an initial level, we will learn those algorithms. Yeah. Uh, as I said, there are two approach. One is the analytics approach, where you can get into the detail and say that these are the active customer, dormant customer, and then you can take all your customers and then write down your SQL queries, pull those information, create these patterns in your SQL queries, and then finally calculate the percentage. How many percent of customers fall under active? How many percent of customers fall under dormant? Out of active and dormant, what are the different visit pattern? Is it a recent visit pattern? Is it a uh, it's all 3 years visit pattern? You can do in that way as well. And the other way is figuring out, and the rest of the things that you guys already mentioned, right? Number of product, those who are falling under dormant, how many number of products that they have purchased versus whether there is any declining trend or not. Okay, in number of products, those who are falling under dormant, those who are falling under active, then whether there is an inclined trend or not, or whether it is a static trend, or whether again there is a dormant trend, downwards trend. So all of those analysis you have to do, and then finally you have to create a report for your stakeholders. This is what I found in the data set. This is what are the different trend analysis, pattern analysis that we can use. Any questions?
So basically, are we going to be, are we going to go through the second approach today? This approach gives you primarily active and dormant customers, and we are yet to predict churn. So some dormant customer could get active also. But can we safely assume dormancy as attrition or churn?
Yes, yes, yes. Can.
Okay. So this is one approach based on primarily EDA. And is there a
Yes.
predictive approach to this?
This further you can do. You can take all the customers and those who are falling under active, create all the features, mark the active customers as one, and mark the dormant customers as is active as one. Mark the dormant customers as zero. Okay, but if I'm going to use predictive analytics, or let's say I'm going to predict the churn rate, then I would not go with this approach, because here I am defining the pattern. What I would do is I would tell the model to learn this approach automatically, just by stating that in a given 2022 years, whether the customer has visited or not visited. That's it.
Mhm.
Here I am defining it clearly. 010 dormant. Maybe he is not a dormant. Maybe he come back in 2022, right? So uh, that's the disadvantage of using this. This is good for our exploration study. This is good for our exploration study.
Okay. Okay.
But not for predictive modeling, because you are introducing a biasness by saying that 110 is a dormant. It can be active as well. 100 is dormant, that is fine. Like last 2 years is not visiting, more likely that this year also will not visit. Any questions, guys?
So Rishabh, how is this course structured? I mean, will we first go through languages and then?
Sorry, I didn't get. Can you repeat once?
I mean, how is the course being structured? So if like there are references of SQLs and Python coming in,
Yes, yes, yes. So
so
first we will learn about. First we'll start in our next session onwards. We'll start with Python.
okay,
Okay, couple of weeks we'll spend with Python,
okay,
and then we will uh, learn a bit of exploration, or means we'll learn a bit of exploration. Or generally, what I do is I take the exploration bit late. Before that, I jump to SQL, so that while I get you through SQL, you get some time to practice with Python. Because exploration task would be a bit heavier, so by the time you need some practice, some handhold on Python, so that you can write down those exploration logics and all. Okay. So first we'll start with Python, and then we'll jump into SQL, and then followed by the exploration, data exploration, and then followed by I will teach few basic predictive algorithms. Predictive algorithms, and then evaluation techniques, and finally you can end up with uh, some of the cloud aspects, as well as Scrum, project design. Those are the different other aspects.
so at
This is our roadmap.
okay, I understand. So what is the stage where will be learning about the statistical concepts?
Starting from next week onwards.
Oh, so
Like
Python, will it?
once we complete Python, we will land up over there.
Okay.
This exploration and predictive algorithm, these are the stages where you will learn all this.
Oh,
At this level, once, so first is Python and SQL. These two are mandatory,
right.
and then in from exploration onwards, we will start.
Oh. Anything you would recommend? In terms of Python, even before you start, is there any practice that we can do on this Python?
No, not required. Once I
Oh,
start, then
oh,
you can go with practice.
oh.
Anybody, any questions, doubts you have?